So another is we are talking about the iterative deepening of DFS. This search algorithm finds out the best depth limit and does it by gradually increasing the limit until a goal is found. First, it finds the best depth limit also. And this algorithm performs depth first search up to certain depth limit only, and it keeps increasing the depth limit after each iteration until the goal node is found. Let's decide it takes the first three limit only. If the node is till that, if the goal node is found, then it's okay. Otherwise, it will increase the depth limit after each iteration. Now, what are the advantages here? As it is a combination, iterative deepening DFS is a combination of both the BFS and the DFS. So we have a both advantages here. It combines the benefits of a BFS and the DFS search algorithm in terms of a fast search, optimal solution, and the memory efficiency also. The main drawback of iterative deepening DFS is that it repeats all the work of a previous phase. It repeats. So here we are talking about the iterative. So how it works? Here we are talking about it's a particular representation of a limit 1. First we are talking about the limit 1. Firstly, the limit 1 will be completely traversed, and then the limit 2. And then in that case, if you find the solution, that is okay. And in level 3, all the further branching will be found. So iterative deepening is basically in limit 3, all the from first node, all the branching will be done. So here we are talking about the repetitions also. And in this graph, we are talking about the goal node is a M here. So when the M will be found, the algorithm will be terminated here. When the goal node will be found. So what we can say, we can conclude that IDS is a hybrid strategy between DFS and a BFS, inheriting their advantage. And the iterative deepening search is faster than the BFS and the DFS. And it is said that IDS is predefined, preferred uninformed search method when there is a large search space and the depth solution we need to find here. So these are the differences between comparison table of a BFS, DFS, and IDDFS. So what's the difference? Somewhere the complexity, time complexity is same in the DFS and the BFS and IDDFS, but the space complexity, because DFS is completely depends on the depth, is D, and in BFS the space complexity is B to the power D, and in IDF it is BD, branching and the depth factor. So when to use the DFS, don't care if the answer is closest to the starting vertex and the root. If the goal node is closest to the starting root node or the starting vertex or the initial state, only use the DFS. When the graph tree is not very big and the infinite, when the graph is not very big, then you need to use a DFS. When to use the BFS? When the space is not an issue. When there is a space is not an issue because the space complexity is high in this. When we do want the closest answers to the root, right? We want the closest answer towards the root, and when we need to have a IDDFS, you want a BFS, you don't have enough memory and somewhat slower performance is accepted. In short, you want BFS plus DFS, right? So in these cases, BFS and the DFS and the IDDFS we have discussed.